Okay, in this video, let's talk about implicit differentiation. Well, implicit differentiation, a lot of time you see in the book, it's when y is not by itself. It's when you got an equation or you got a function that when y is not just y, but y is either y squared, y times y, or y to like any power, or it's when y is multiplying another variable such as x. But after you knowing pretty well, like after you learn the rules of all derivative, and after you know how to do the chain rule, like implicit differentiation won't be so hard for you, because we have been actually, even when you were taking like all the derivative that you have taken, you actually did that with implicit. You did that the same way that you solve an implicit differentiation. Because remember, all before we are solving for y prime, and the expression, the function is like this, right? And you are still taking, when you try to find y prime, you are still taking the derivative of both sides. See that? Because the derivative of y is y prime. You may think it's 1, but it's not, because remember, you are trying to find y prime, so you cannot make y the derivative to equal 1. You cannot do that, because you want to find y prime. So yeah, you're still taking the derivative of both sides. See that? You take the derivative of y, which is y prime, and if you take the derivative of 2x plus 1, the derivative of that is just 2. So you solve the problem this way. Just like even when you have more complicated form, when y equal, like in which you have to use the chain rule to solve for two thing. Yeah, remember? Because you see, you take the derivative of y first, which is derivative of y is y prime, and then you take the derivative of this expression here, and which you remember, you rewrite that as 2x plus 1 to the 1/2 power, using the power rule, make it into 1/2 2x plus 1 to the negative 1/2. But not finishing yet, because you still have the 2x plus 1 inside. 2x plus 1 inside. So you take the derivative of that, which is 2, and then you just multiply that 2 with the previous derivative you have find. And right now, let's do an example of implicit differentiation. This example is also, I found one from the book, like try to find the easiest one to start. 3.7, number 1, and you can also find the answer from the answer menu, or you can find it in your head. Pretty sure it's already in your head. Okay, so it's number 1, 3.7, and the question, it's x squared times y plus x times y squared equals 6. So always taking derivative of a function or an equation like this, you are taking derivative of both sides. Taking derivative of both sides, if you take the derivative of this thing here, you have to use the quotient rule. See that? Because x squared times y, you got two things here. A product rule, sorry. Whoa. What's wrong with me? Okay, I'm talking about the product rule. So you have to do that. And let's do the product rule in a different page. Remember, the product rule is just g times the derivative of f plus f times the derivative of g. So remember, that is x squared times y. In this case, y would multiply the derivative of x squared, which would just be 2x, right? 2x, and then you will add x squared to times y prime, because the derivative of y is not just 1, because you are trying to find y prime, so you have to keep the y prime here, right? You have to keep the y prime. Whatever derivative that you have to find, you have to keep that. Remember? I keep saying the word remember, oh my gosh. Okay, so what am I trying to say? Okay, so whenever you're taking a derivative of something, let's say if you want to find s prime for a question, then the derivative of s is not 1, it's always s prime, because you are trying to find s prime. Okay, so that's the point. Just want you to remember, because I remember you asked me the question before. Alright, so now this thing here is the derivative of x squared times y. So we'll write it back into the question before. So we would just, what, 2xy plus x squared y prime. So it will be 2xy plus x square y prime here, and then we will add another quotient rule, product rule actually, using product rule to solve this again. Go to that page. It is, this time it's x times y squared. So g will be y squared times the derivative of x is 1. Now this time the derivative of x is 1 because we're not trying to find x prime, so the derivative of x is 1. And then we just add x times, now the derivative of y squared, what would that be? It's the same thing as you taking the derivative of x. It will be 2 to the y, right? Because power root 2y. But after you taking, remember, you're using the chain rule again. You're using chain rule here. The chain rule, the outermost layer is y squared. But then the inside layer, the inside part, the inner part is y. So that's why after you're taking the derivative of y squared, you will have to take the derivative of y too. So that will give you y prime. Alright, so with times 2y times y prime. Alright, so now we will write that back into the equation which from the other page, which is y squared plus 2xy the right prime. Okay, so you will add another okay, you add another part here, which is, it was what was that, just forget, but I know this one is plus 2xy y prime. This one was that y or just 2y, can't remember. Y square. Okay, y square. The square has squared at me, that's why I forget about it. Okay, so y square. So now we have done taking the derivative of the left side of the equation. It's all here. Now we just have to take the derivative of the right side of the equation, which derivative of any constant that is just 0, right? 0. Okay, so now since we want to find, what we need to find is y prime, so we really have to combine this equation, combine the expression, and try to find a way that we can isolate everything else from y prime. So first, to do that, we'll see if we can combine anything. We cannot really combine anything, so what we have to do right now is, like after we know we cannot combine anything, so after that we just, since we want to isolate y prime from everything else. So everything that do not have a y prime with it, we'll move it to the other side of the equation. So which will just give us, so the left side will be just x squared y prime plus 2x y prime, right? And then the other side of the equation, since we move two things over there, we negative 2xy minus y squared. Okay. Now, I ran out of space. Or okay, we can do this. Okay, let's look at here. Since y prime is still on the left side of the equation, right? And we want to isolate y prime from everything else. So we have to find a way to do that. And if you are seeing what I'm seeing, then you see that both of the things has a y prime here. So which means we can factor out the y prime from this two number here. So after we factor them out, it will be y prime, the left side will be y prime times x squared plus 2xy. And remember, the left side is still here, still the same, we haven't changed anything. So, whoops. Okay, so now if we want to isolate the y prime completely from everything else, from this thing here, we will just define both sides by x squared plus 2xy, right? So that's how you solve for an implicit differentiation. When you're taking a derivative, you're using a chain rule, and you're using a chain rule to take the derivative. But then after you're taking a derivative, you just try to isolate y prime to solve for y prime. So now let's do another example. This time I'm gonna pick an example from my own, because yeah. Okay, now let's try to solve this implicit differentiation. It's x times y equal x times sine of xy. Alright, remember, first thing of implicit differentiation, we are finding y prime. We are finding y prime here. We can find x prime and anything. We can find x prime, but the question here, we ask for y prime, so we have to solve for y prime. So now take the derivative of both sides. This derivative, product rule, and again using the other to do the product rule. Be y times derivative of x is just 1, remember, and then add x times the derivative of y prime is not 1. The derivative of y is y prime. So just y plus xy prime. Y plus xy prime. Okay, now this sign, again, we see an x here, and then we sign a sine something here. So that's a product rule as well. So we're going to do it on the other page. And that was x sine xy. Take the product rule of this, which is gf plus fg. We'll write sine. Oh, you know what? I'll write it. Okay, we'll say here's sine xy, right? Because we just write down the g function without doing anything to it, and then we will times multiply by the derivative of x, which is just 1, and then we will add x times derivative of sine xy. When you see here, you have to know that, like, you see that this is the chain rule, right? Because it's not just sine something, it's sine that something is a product here. So you know it's going to be a chain rule. So the outermost layer is the sine of something. So if you remember, or let's look at here the chart, right? The sine of something, it's cosine of something. So the derivative of that is, so here you multiply the cosine of xy, right? And no negative sign here because this function is sine. It's not any function that any trig function that starts with a c. So now the next, remember, we look back and into the expression and see if we are done by just taking the derivative of sine something, but it is not, because inside the sine something, the inner part is a product x times y. So we have to take the derivative, take the product rule for x times y. We have to find derivative of x times y. So let me erase this real quick so it can be more clear. Okay, remember we're using the chain rule here, so we are using chain rule here, so it was this times x times y. Okay, we have done else but except for taking care of this x times y here. So we will take the product rule of this, and which will give us y times 1, right? Add x times y prime, right? Because, and then we just multiply, remember, multiply this derivative with the derivative that you got before. So here, let me use a parenthesis to take this. So the derivative of sine xy, it's this entire thing here that I'm using the red pen underlying. This whole thing here is the derivative of sine xy by taking the chain rule. And with the x here, that's the derivative of, or no, with this part here, with this part, even this the part of the with the plus sign, this entire thing, this sine xy plus times 1 plus x times cosine something, this entire thing is the product rule, is the derivative of x times sine x times y. Okay, so we move this back into our previous equation. This will be sine x sine xy plus x times cosine xy times, that was y plus x y prime, y plus x y prime. Okay, so yep, so that's the entire thing here. Okay, so right now remember now we done taking the derivative of both sides of the equation. Now we have to, the next step that we have to do is to isolate y prime. So since I ran off page, so let's move the entire thing to here. To isolate y prime, let's move, well, first thing first. See, here's the product. I'm using a blue underline here. See, this is a product. This is a product, so we have to distribute first, because we have to distribute first the product, because we see the y prime is hiding inside here, so we have to distribute first, because we want to isolate y prime and it's hiding, so we have to distribute first. Okay, so first step, let's move to here, to this page. Is y plus xy prime equal y plus xy prime sine xy add x times. Now let's distribute the inside, right? Because since this is cosine of xy times these two numbers, so let's distribute. So this will become the y cosine y. So inside the parentheses will be y cosine of xy add cosine of xy times xy prime, so it will be xy prime at xy prime times the cosine of xy here. Alright, now we have to distribute the inside. Now we also have to distribute the outside with the x, because yeah. So let's distribute that, and okay, let's rewrite that. X plus xy prime equal sine xy. Just rewriting the question right now, and now we distribute. So it will be xy cosine of xy. Sorry about my writing, because writing on computer is really messy. Okay, now, and what would that be? Tell me. That would be just x squared, right? X squared y prime of and cosine xy. Alright, now after we distribute, and then we will try to isolate y prime. We see that the things that with y prime is only xy prime and x squared y prime. This everything else, I'm using the red to underline everything else. Okay, now everything else here don't have y prime, so we'll group them together on one side, and then we'll group the y prime together on one side. Okay, let's do it on here. Sorry about keep changing the page, because the laptop is really small screen. Okay, so if we are changing, oh, you know what? Let's do it step by step. I don't want to confuse you. I'm just rewriting the question right now. So rewriting. Okay. Let's sine xy and plus x cosine y. Okay. Sine xy plus okay, y cosine y, well, cosine xy okay, that's xy. Okay, xy cosine y plus x squared y prime cosine xy. Okay, so now moving group the y prime together, so we'll move this guy to the left, so it will become to the left, then will be y prime minus x squared y prime cosine xy, and then we'll move this y here to the right because it has nothing to do with y prime, so that will make it sine xy, make the right sine xy, at xy cosine of xy minus y. Yep. Okay, so now same thing before, we want to isolate y prime with everything else. So if we look at this portion here where y prime is, we'll see that we are able to factor out y prime, so we just become this minus x squared cosine xy, and the right side of the equation will be the same still, you know, sine xy blah 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 all the way to minus y. And to solve for y prime, you just define this one, define the right side by this part that I'm putting makeups on, this one. So let me show you the final answer. Okay. The final answer will just be y prime equal sine xy cosine of xy. Of course, this multiplying the xy, right? And then you minus y, and then you just divide everything by x minus x squared cosine cosine xy. Yep, that will be your answer, because you are trying to solve for y prime, and here is your y prime. So, and yeah, so all the implicit differentiation question will be solving like this. I guess I'm done here. I remember we may need the original question. The original question was xy equal x sine xy, and after solving the implicit differentiation, y prime becomes this. So yeah, alright, so good luck, and not that you need that much, because I'm pretty sure you knows, and just believe in yourself, and you are much smarter than you think you are. So yeah, so just believe in yourself. Believe in yourself, don't stop believing, hold on to the feeling. Okay, I'm being stupid here, so alright, goodbye.